Hello everyone, I am Megakshi Rana, your mathematics teacher on Study Room. I welcome you all here to our first video lecture of class 8 mathematics, that is chapter 1 rational numbers. So in this video we will learn about types of numbers and then we will learn more about what are rational numbers and about their properties, and at last we'll also do some examples related to it. So let's hop on to the first slide, that is numbers. Let's see the first type of number here, that is the natural numbers. What are natural numbers? Natural numbers are the set of numbers starting from 1 and counting up to infinity, denoted by a capital N. So the natural numbers are the numbers that are denoted by a capital N, and they start from 1 and they go up to infinity. So these are natural numbers. The next type is the whole numbers. Whole numbers are the set of numbers starting from 0 and going up to infinity, denoted by capital W. So we denote whole numbers by a capital W, and whole numbers start from 0, 1, 2, 3 and they go up to infinity. These are whole numbers. Next is integers. What are integers? Integers are the set of all positive and negative numbers including 0. These are denoted by capital Z. So we denote integers by Z, and integers include 0, include these positive numbers 1, 2, 3 up to infinity, and they also include the negative numbers that are -1, -2, -3 and so on. So these are integers. Next we see here, what are we seeing? We are noticing that here we are given natural numbers. See, we are given natural numbers that are 1, 2, 3 and so on. Now, if we include 0 to these natural numbers, what do we get? We get whole numbers. So, by including 0 to natural numbers, we get whole numbers. And if we include the negative numbers that are -1, -2, -3 and so on to the whole numbers, what do we get? We get integers. So by adding 0 to natural numbers, we get whole numbers, and by adding these negative numbers to the set of whole numbers, we get integers. So starting from natural numbers, we can get whole numbers, and then we're coming to integers. So these were the types of numbers. The next type that we are going to study more about in this chapter is rational numbers. First of all, let's see what are the rational numbers. The numbers which can be written in the form p by q, where p and q are integers and q is not equal to 0, are called rational numbers. So, and we denote, the rational numbers are denoted by a capital Q. So, what are these rational numbers? Any number that is of the form p by q, where both these p and q belong to these rational numbers. What I'm writing, both these p and q are integers. We just read that both these p and q are integers, can be any negative number, -1, -2, -3, or any negative number, can be 0 and can be any positive number, but there's a condition on q that q should not be equal to 0. Q should not be equal to 0, because if q gets 0, then this number is not defined, so it cannot be a rational number in that case. So the rational numbers are denoted by q, and all the numbers that are of the form p by q, where both p and q are integers and q is not equal to 0, then such numbers are called rational numbers. Examples are 6 by 7, -2 by 3, 9 by 5. All these are rational numbers because all of these are written in the form p by q, where q is not equal to 0 and both p and q are integers. So we just saw this, and these rational numbers we have added here, 1 by 2, 3 by 2 and so on. So all these are rational numbers. When we add these fractions also to integers, what do we get? We get rational numbers, denoted by capital Q. Let's hop on to the properties of rational number. The three properties written here are closure property, commutative property, and the third one is the associative property. The first one is the closure property. Closure property means that a set is closed for some mathematical operation. Example, 2 and 5 are integers, then the addition of integers, that is 2 plus 5 equals to 7, also gives an integer, hence closed under addition. So what is written here? Here it is written that since 2 is an integer, 5 is an integer, and when we add 2 and 5 we get 7, which is also an integer, This is Z. 7 is also an integer. So we can say that this is closed under addition. Now we'll see this table, and this table is for the closure property for which numbers? Whole numbers. So first of all, the operation given to us is that of addition. And we have an example, that is 0 plus 5 equals to 5, a whole number. And we conclude, from this example, what do we conclude? We conclude that the whole numbers are closed under addition. Why is that? This is so because 0 is a whole number, 5 is a whole number, and when we add both these whole numbers, we are getting 5, that is also a whole number. So we can say that whole numbers are closed under addition. Next operation is subtraction. Let us see about it. So 5 minus 7, when we subtract 7 from 5, we're getting minus 2. But is minus 2 a whole number? No. Here 5 is a whole number, 7 is a whole number, but minus 2, that is our answer, is not a whole number. So we can say that the whole numbers are not closed under which operation? Subtraction. Our next operation is multiplication. See, when we multiply 0 with 3, this is also a whole number, 3 is also a whole number. What are we getting? We're getting the answer 0, which is also a whole number. So we can say that whole numbers are closed under multiplication. The last operation is that of division. Just see here, 5 divided by 8 is, this gives us 5 by 8, that is 5 by 8, okay? Is 5 by 8 a whole number? No, this form is never a whole number because this is a rational number and not a whole number. So we can say that the whole numbers are not closed under division. So what did we get from this table? We concluded that whole numbers are closed under addition. Whole numbers are not closed under subtraction, but are closed under addition, are closed under multiplication, but are not closed under subtraction and division. So the whole numbers are not closed under subtraction and division. We just saw from this table and these examples. The next is closure property for integers. So our next table is that of closure property for integers. The first operation is addition. We are again going to see just like the previous table. Here the example is minus 6 plus 5. That is minus 1, which is an integer. So minus 6 is an integer, 5 is an integer, and the answer minus 1 is also an integer. So we can say that integers are closed under addition. These are closed under addition. Next operation is subtraction. We are subtracting 5 from 7 and we are getting 2. Both these 7, 5 are integers and the answer, that is 2, is also an integer. So we can say that the integers are closed under subtraction as well. Next operation is multiplication. When we multiply 5 with 8, that is when we multiply an integer with an integer, we are getting 40. That is also an integer. So we can say that integers are closed under multiplication. And the last operation is that of division. So in this example, we are dividing 5 by 8 and we are getting this answer in this fraction form, that is 5 by 8. But is 5 by 8 an integer? No, 5 by 8 is not an integer. This does not belong to the set of integers. This does not belong to the set of integers. So we can say that the answer is not an integer, hence integers are not closed under division. Not closed under division. So what do we conclude? That in the case of this closure property for integers, integers are closed under addition, are closed under subtraction, are closed under multiplication. That is what we saw from these examples. But integers are not closed under division. Integers are not closed under division. We just saw it from this example. We concluded it. The next property is the closure property, but this time for rational numbers. The first operation here is addition. We are adding 3 by 8 with minus 5 by 7 and we are getting minus 19 by 56. That is, two rational numbers when added gives us a rational number. So we can conclude that rational numbers are closed under addition. Next operation is subtraction. See, when we subtracted 2 by 3 from a rational number, that is minus 5 by 7, we saw that our answer was minus 29 by 21, which is a rational number. So we're taking two rational numbers, we are subtracting one from the other, and we're getting a rational number again. So we can say that rational numbers are closed under subtraction. The third operation is multiplication. We are multiplying minus 2 by 3 with 4 by 5. That is, we are multiplying two rational numbers and the answer we are getting is minus 8 by 15. That is also a rational number. So, rational numbers are closed under multiplication as well. The last mathematical operation here is division. So, take for an example, 5 when divided by 0 is not defined because here we will get 5 by 0. Here our P by Q is 5 by 0 where Q is 0 but Q should not be 0. For P by Q to be a rational number, Q should not be 0, but in this case Q is getting 0. So this is not defined, this is not a rational number, and we can say that rational numbers are not closed under division. So what are we concluding in the case of rational numbers? Rational numbers are closed under addition, are closed under subtraction, are closed under multiplication, but rational numbers are not closed under division. We concluded it by taking this example. Now, what did we study about the closure property for rational numbers? That for any two rational numbers, a and b, a plus b is also a rational number. That is for both a and b, belonging to rational numbers, our a plus b is also a rational number. For any two rational numbers a and b, a minus b is also a rational number. That is, again, if we take a and b to be rational numbers, our a minus b will also be a rational number. In the case of multiplication also, our a multiplied by b will be a rational number. But when we take a rational number a, we divide it by 0. In that case, a divided by 0 is not defined. So we can say that the rational numbers are not closed under division. This is exactly what we saw from the previous table, that the rational numbers are not closed under division. But what if we exclude 0 from this set of rational numbers? This is our Q star, take it as Q star. That is a set of all the rational numbers from where we have excluded the number 0. So in that case, if we exclude 0 from the collection of all the rational numbers, then this set, that is Q star, that is 0 excluded from all the rational numbers, is closed under division. Because in that case, we will get P by Q always, where Q will not be equal to 0, P will also not be equal to 0. So this will be defined and will be a rational number. So it is closed under division in that case. So let's just hop to some more properties of rational number. This is the part 1 for the other properties of rational number. What is the next property? The property here is commutative property. So when this property states that the numbers on which we operate can be moved or interchanged from their position without making any difference to the answer. What does this mean? This means that, for an example, take 2 plus 3. When we add 2 with 3, we get 5. And also, if we just interchange their position, we write 3 plus 2. What do we get? We again get 5. That is, this property states that the numbers on which we operate can be moved. We can move the numbers, we can interchange their position without making any difference to the answer. If we add 2 plus 3 or if we do 3 plus 2, we are getting the same answer, that is 5. So this is what is a commutative property. Let's see this table. This is the commutative property for whole numbers. Now in the case of addition, we are adding 0 plus 7. That is also equal to 7 plus 0 and that is equal to 7. So we say that addition is commutative. Now in the case of subtraction, see, if we minus 5 from 0, that is 0 minus 5, what is the answer? Minus 5. But if we do 5 minus 0, what do we get? 5. Is minus 5 equal to 5? No, minus 5 is not equal to 5, or we can say that subtraction is not commutative. Addition is commutative, but the subtraction in the case of whole numbers is not commutative. Because if we interchange their positions, the numbers' positions, we are not getting the same answer. Next operation is that of multiplication. If we multiply 4 with 5 or we do 5 into 4, is the answer same? Yes. 4 into 5 is also 20. 5 into 4 is also 20. So multiplication is commutative. Multiplication is commutative. The last operation is that of division. So just see, 5 divided by 0 is not defined. When we do 5 by 0, this is not defined. But 0 can be divided by 5. The answer is 0. 5 cannot be divided by 0, but 0 can be divided by 5. The answer in both the cases are not same. So we can say division is not commutative. So in the case of commutative property for whole numbers, we saw that addition is commutative, subtraction is not commutative, multiplication is commutative, and division is also not commutative. We took these examples and we concluded these things. The next up here is commutative property for now integers. In the case of addition, see, 2 plus 7 equals to 7 plus 2 equals to 9. We have taken this example and we can conclude that 2 plus 7 equals to 7 plus 2 equals to 9. Therefore, addition is commutative. Now, if we subtract, in the case of the operation that is subtraction, 5 minus 3 equals to 8, okay? But minus 3 minus 5 equals to minus 8. So in this case, 8 is not equal to minus 8. That is, our answers differ in both these cases. So we cannot say that 8 is equal to minus 8. That is why subtraction is not commutative. We conclude that subtraction is not commutative. Now in the case of the operation multiplication, 4 into 5 is 20. 5 into 4 is also 20. So multiplication is commutative. And the last operation is division. Just see from here, 4 divided by minus 5 is minus 4. But minus 1 divided by 4 is minus 4. So if we divide 4 by minus 1, we get minus 4. But if we just interchange the positions. That is, we divide minus 1 by 4, we get minus 1 by 4. Is minus 4 equal to minus 1 by 4? No, it isn't. So what do we conclude? That division is not commutative. So in the case of commutative property for integers, addition is commutative, multiplication is commutative, but subtraction and division are not commutative. Next is this commutative property for rational numbers. So in the case of addition, see, we are adding minus 2 by 3 with 5 by 7, and the next we are adding 5 by 7 with minus 2 by 3. In both the cases, the answer remains the same, that is 1 by 21. So we can say addition is commutative. Addition is commutative. See. In the case of subtraction, when we subtracted 5 by 4 from 2 by 3, we got minus 7 by 12. But when we subtracted 2 by 3 from 5 by 4, that is, we just interchange their positions, we are getting 7 by 12. But both these minus 7 by 12 and 7 by 12 are not equal, therefore subtraction is not commutative. Subtraction is not commutative. Next we are having multiplication operation. Minus 7 by 3 multiplied by 6 by 5 equals to 6 by 5 when multiplied with minus 7 by 3. Both the answers are same and we can say that multiplication is commutative. The last operation is that of division. When we divide minus 5 by 4 with 3 by 7, we get minus 35 by 12. But when we interchange these two numbers positions, that is when we divide 3 by 7 with minus 5 by 4, we get minus 12 by 35. You can just see from here that minus 35 by 12 is not equal to minus 12 by 35. That is, division is not commutative in the case of rational numbers as well. So when we took rational numbers and we saw the commutative property for the rational numbers, we concluded that addition is commutative, multiplication is commutative, but both the subtraction and division are not commutative. So for any two rational numbers, but just see that if A and B both are rational numbers, then we can say that A plus B will be equal to B plus A. Addition will be commutative. We cannot say that in that case A minus B will be equal to B minus A. These are not equal. So we can say that subtraction is not commutative for rational numbers. But we can always conclude that A multiplied by B will be equal to B multiplied by A. That is, multiplication is commutative for rational numbers. But in the case of division again, we cannot say that A divided by B will be equal to B divided by A. These will not be equal. So we can say that division is not commutative for rational numbers. This is exactly what we concluded from this table of ours. This is the conclusion. What do we have next? The next property that we have is the associative property. So this property states that addition and multiplication of numbers are possible regardless of how they are grouped. By grouping, we mean that numbers which are given inside these parentheses, inside these brackets. That is, it does not matter that how the numbers are grouped, but the addition as well as their multiplication will be equal in both the cases. The way that how they are grouped, that does not matter in this case. That is, if we have written here that 5 plus 6 are in the parentheses and after that we are adding to this number, we are adding 2, that will remain the same when we add 6 to this sum. That is, if we do 2 plus bracket 5 plus 6, that will be equal to 2 plus 5 brackets plus 6. In both the cases, the answer that we get is 13. Let's see this associative property for whole numbers first. Operation is addition. Example here is 2 plus 0 plus 5 equals to 2 plus 0 plus 5. You can just do it on your own. Both these cases, the answer will be 7. So we can say that addition is associative. Addition is associative in the case of whole numbers first. But in the case of subtraction, when we are doing 2 minus 4 minus 5, this will be 2 minus 4 minus 5 will be equal to minus 1. 2 minus minus or 1 will be equal to 2 plus 1, that is 3. But in this case, when we do 2 minus 4 and then minus 5, 2 minus 4 will be minus 2. Minus 5, that is minus 7. The answers in both these cases are different, not same, unequal. So we can say subtraction is not associative. It is not associative. Now our third operation is that of multiplication. Let's see the example. It is 4 into 2 by 3 and it's written that it'll be equal to 4 into 2 into 3. That is, both are equal to 24. Let's just see. 4 into 2 into 3 is 6. That is 24. Again, 4 2s are 8. 2, 3. Both are equal to 24. So the way of grouping does not matter here. So we can conclude that multiplication is associative. Next up here is that of the operation of division. When we divide 4 with 6 divided by 2, the answer that we are getting is 4 by 3. See, 4 divided by, first of all, we need to solve 6 divided by 2. This will be this. 4 divided by 3. We are getting 4 by 3. The answer we are getting is 4 by 3. But when we group it in this way, that is 4 divided by 6, and then it will be divided by 2. What do we get? 2 2 are 4, 2 3s are 6. It will be 2 and then 3, 2. The answer, final answer we are getting is 1 by 3. Is 1 by 3 equal to 4 by 3? No. Both these answers are different, are unequal, not equal. So we can say that division is not associative. So addition is associative, multiplication is associative, but both these subtraction and division are not associative. Let's just see the next table, that is the associative property for integers. What about this? In this it is written that in the case of addition, minus 2 plus 3 plus minus 4 will be equal to minus 2 plus 3 plus minus 4 equal to minus 3. If you will solve this example, you will get in both the cases, you will get the answer as minus 3. So the addition is associative for integers as well. But when you will again do the subtractions, in both these cases, you will see that the answers are different. In the first case, when we are grouping 7 with 3, the answer is 1. But in this case, when you're grouping 5 with 7, the answer is minus 5. Therefore, both these answers are not equal. Therefore, subtraction is not associative. In the case of multiplication operation, when we are grouping any of the two numbers together, the answer that we are getting is the same, is equal. So we are concluding that multiplication is associative. But again, in the case of division, when we are dividing three numbers and we are grouping these numbers in two different ways, first of all 10 with 2 and then 2 with 5, first of all minus 10 with 2 and then with 2 and with minus 5, the answers we are getting are not same. They are not equal. So we can say that division is not associative. What are we concluding? That in the case of associative property for integers, addition is associative, multiplication is associative, but subtraction and division, both these operations are not associative. Now let's check this property for rational numbers. Here we are taking any three rational numbers, we are grouping these numbers in two different ways, and when we are adding these three numbers, we are getting the same answer. You can just check this example by your own as well. You will get the same answer, that is minus 9 by 10. Therefore, we conclude that addition is associative. In the case of subtraction, when we take three rational numbers, we subtract these three numbers from each other in two different manners. By grouping these three numbers in two different manners, the answers we are getting are not equal. So we say that subtraction is not associative. Next, in the case of multiplication operation, when we are multiplying any three rational numbers, say in this case we are multiplying minus 7 by 3, 5 by 4 and 2 by 9, in two different manners, when we are grouping these three numbers in two different manners, we are getting the same answer in both the cases. So we say multiplication is associative. The last operation is that of division. See, we have taken an example, we are dividing 1 by 2 with minus 1 by 3 and also 2 by 5. But first of all, when we are solving minus 1 by 3 divided by 2 by 5 and then we are dividing 1 by 2 by this answer, we get minus 3 by 5. But in this case, when we are solving 1 by 2 divided by minus 1 by 3 first, and then the answer that we get here, when we divide that answer by 2 by 5, the final answer that we get is minus 3 by 2. We can see that both these numbers are not equal, that is, both the answers are different. So we conclude that division is not associative as well. That is, in the case of rational numbers, addition is associative and our multiplication is associative. But this division operation and this subtraction is not associative in the case of our rational numbers as well. Let's just conclude it, what we have seen from this table, that in the case of A, B, C being three rational numbers, this A plus B plus C equal to A plus B plus C, both of these will be equal. But this will not be equal to this, that is, subtraction will not be associative. When we are doing multiplication, that is A multiplied by B multiplied by C and A multiplied by B multiplied by C, then we see that the answers are equal. So we say multiplication is associative for rational numbers. But for any three rational numbers A, B, C, when we divide these three numbers, that is A divided by B divided by C, or we do A divided by B divided by C, the answers are not equal. So we say that division is not associative for rational numbers. This is exactly what we concluded from our previous table. So here we are finally with our example number 1. Example written here is find 3 by 7 plus minus 6 by 11 plus minus 8 by 21 plus 5 by 22. So you can do this, you can solve this question in two manners. You can easily just do it in the form that it is written, or you can just club the two numbers together and the other two numbers together. You can solve it in this manner. I'll do it in the second way. I am clubbing 3 by 7 with minus 8 by 21, and I'll solve this together, and then I'll add the other two numbers, that are minus 6 by 11 with 5 by 22. Let's solve it. Here, when you take the LCM, you know how to take the LCM of two numbers, that is 7 and 21. We have 7 and 21. So the LCM for both these numbers will be 3 sevens are, that is 21. And when you will solve it, you will get this. And in this case, when you will find the LCM, you will get it as 22. The LCM here in this case is 22. And you will just solve these. You will get, now solve these two. 9 minus 8 is 1 by 21. And here it will be, when you subtract, when you do minus 12 plus 5, you will get minus of 7. You can just write it, plus minus will be minus 7 by 22. Now in this case, our LCM will be 21 into 22. Just do it in the rough work. You will, what do you get? 2 1 are 2, 2 2s are 4, 2 1s are 2, 2 2s are 4, that is 462. And when you solve it, you get, what do you get here? Divided by this, multiplied by this, and in this case, you'll get 21 multiplied by 7 minus 147. This is the final answer that you get. So this is how I solved these four numbers. We just had to add these four rational numbers, and this is how we solved it. The final answer that we got is minus 125 by 462, which is a rational number as well. What is our next example? So the next example is that of multiplication. We are multiplying four rational numbers. Minus 4 by 5 into 3 by 7 into 15 by 16 and into minus 14 by 9. How will you do it? You can do it just by multiplying all these 4 numbers together or by multiplying 2 numbers together. I'll do minus 4 by 5 with minus 15 by 16, and after solving this, I'll then solve these numbers with this. Okay, so I'm clubbing these 2 numbers together and these 2 numbers together. Why am I doing? Because then you can simplify it easily. And here also you can do it. What do you get when simplified? Minus 3 by 4 into, here it is, minus 2 by 3. So the final answer here is 1 by 2. So how did I go about solving this example? I clubbed these 2 numbers together, and I simplified these fractions by multiplying and cross multiplying, dividing each number. And the final answer that I got for this solution, for this example number 2, is 1 by 2. So this is our final answer. So this was all about our video 1. Thank you for joining me on Study Room. What did we learn in this whole video? We first of all learned about the types of numbers, and then we hopped on to our main topic, that is rational numbers. We studied some of the properties in this video for the rational numbers, and in the next video we are going to do other properties of rational numbers, that is the part 2. We'll do it in the next video. Till then, have a good time. Bye bye. Thank you.